multiplying rational expressions. Remember, rational expression, just like the term ratio, fraction. Multiplying fractions, think back. If I had 3/5 times 2/7, if I were to try multiplying those, remember when you multiply fractions, top times top, bottom. Multiplication is the easy one that we want to do. Top times top, straight across. Bottom times bottom, straight across. Reduce when necessary. Same thing with rational expressions. Even though they're polynomials, now, when I multiply top times top, what I have is this binomial, 10x plus 20, times this binomial, x squared minus 1, divided by this trinomial, 2x squared minus 3x plus 1 times 5x plus 10, this binomial. Now, I could start distributing and combining and go, but that's the last thing I really want to do here, because my next step, I would want to reduce. Well, to be able to reduce, I'm going to need a factor, which is the exact opposite of distributing. So what I want to do is actually factor these first. Now, before we go on too much, instead of saying this binomial times this binomial, the way that I like to show that's easier, if I were going to multiply rational expressions, all I need to do is connect that fraction bar. Notice that if I just put parentheses, that is already the product that I'm going for. So when I do this problem, completing that and then factoring, I wouldn't want to do that. The more we try to transcribe, the more we try to copy over these problems, the more prone we are to missing a sign, missing a number. Some of those routine mistakes, finish the fraction almost the way you copy it, and then start factoring. I'm going to factor by shape here. That square, GCF. Factor out of 10, I end up with x plus 2. There's how the square factors. Times, let's put this one as a circle. Oh, it's my difference of squares. X plus 1 times x minus 1. There's the circle. Now, I'm going to jump over to this one, since it's just a binomial again. GCF, 5, factor it out, x plus 2. I'm going to leave that one as a triangle. Now, when we look at this one, that is the one that has the leading coefficient of the 2. That's the one that would be the AC method, divide and conquer, factor by grouping. But, as we showed last time, let's try to make some assumptions that could make this quicker and easier without going through that method at all. I'm going to see that x plus 2 already cancels. What I want to do is guess and check. It could be the plus, it could be the minus. I'm going to guess, since that's a plus 1, I'm going to try an x plus 1 and just see how it goes. When I have that x plus 1, remember my other binomial is going to be, if that's an x, what I would need is a 2x, because that gives me a 2x squared. If that's a plus 1, to get my constant, what I would need is another plus 1. That would give me a plus 1 times a plus 1 gives me that positive 1, but then I got to check that middle term. 2x times 1 is 2x. 1 times x is x. And what I end up with is a positive 3x. Because that's positive, that was a complete waste of time. That one's not going to work. And that's what I mean by sometimes it works, sometimes it doesn't. But what I can do now is still check that x minus 1. Look at that x minus 1. If I try the x minus 1, I would still need a 2x, because 2x times x is what gives me that 2x squared. But now what I'd have is, to get a plus 1, I would now need a minus 1, because minus 1 times minus 1 gives me that plus 1. 2x times negative 1 is negative 2x. Negative 1 times x is negative x. And when I combine those, there's my negative 3x. That's the corrective accurate form. This could have been a complete waste of time too. And remember, I don't even need to do any of this. I could just do 2 times 1, make a table, find out what gives me 3, split up. I could go through that whole AC method just like we did the other day. But if I have these shortcuts, this can sure save a lot of time. And most of this will end up being mental anyway when we work through these problems. Let's call this that parallelogram. That was just this bottom corner. And again, this is kind of worthless to me now that I have that factored. But my entire goal, once I have these factored, then I can start canceling. I already have my x plus 2's. That's what helped reduce what I would need to guess here. But hey, that minus 1 is what cancels. That 5 and that 10 cancel, leaving me a 2. And I could put a 1, but remember, I don't put that 1. What's left in my numerator? A 2 times x plus 1. What's left in my denominator? All I have left is that 2x minus 1. Again, it's very important which ones have parentheses and which ones don't, because that 2 applies to everything inside. That 2 applies to just that first term.